Welcome back to the third episode of the Best Robotics Programming series. Today we're just going to be going over the basics programming in Robot C. So once you open up Robot C, you just want to click New File right here. You should get a blank window beside this task main code. Let me increase its size a bit so you can see better. First, you're going to go to Motor and Sensor Setup. This is where you put which motors are in which port. You can't really program anything until you do this. So for port 1 and 10, you have to keep in mind these are special ports that only work with non-legal components. So these are for like special VEX motors that we're not given for the game. So just only use ports 2 through 9. So for port 2, let's set it up with a large motor. This can be any name you want. I'm just doing that. And then for here, you want to select 393. That is the large motor. I actually haven't found any difference between switching these, but I mean, just go with 393 since that is the large motor. Then for the next one, we'll go small motor. And that one is a 269 motor. And then lastly, we'll do a servo. And that one is just a 3-wire servo. You can reverse this. This is useful for if you have left or right side. I don't really mess with drive side. It's basically the same as clicking reverse, so just don't mess with it. Coder ports, they do not matter. Leave it a none. PID controller, we don't have access to that. Alright, you want to click OK. And it should automatically create some code for you up here. And this will name our ports and name them as our large motor, small motor, and servo. So the first thing every program basically needs is a while true loop. So what this does is it loops infinitely. Add curly brackets so that everything inside here will loop. If you don't loop infinitely, your entire thing of code will only run one time, which means that you really won't do anything in that one cycle. But for this, we are gonna leave it to run forever because we want to continually use the robot. You could also do 1 equals 1. I just like true because it's nice and simple. So first, for the most basic thing, you could do an if statement, and you could do if the VEX RT. So this is the VEX remote controller. And then you're going to do square brackets, and then btn 5d. So this is button 5 down. I'll get into later which buttons are which, but this is the trigger button. So button 5 down, and then we're going to do equals 1. So the double equals, that means it's comparing this value on this side to this value on this side, and that just means if this value equals this value, then run whatever inside the true condition. So let's set that up right now. Oh, also, if your formatting's all off, say stuff is down here and stuff, just click this fix formatting button and it will reformat everything. So you want to do a motor command, so you can go mo motor, and then you'll do 2 square brackets, and you'll want to do large motor. So this is telling your large motor to be equal to 127, which is the max speed. So the reason it's 127 is not that confusing. It's basically you have 8 bits of binary. So you have 8 bits, and 127 is these last 7, and this last bit is for positive or negative. So basically the max value you can put in here is 127, and that means it will output max power to the motor. And it goes the same way with servos, because the servos have a max range, and so it's when you're plugging in values here, don't imagine it as degrees or RPMs. Just imagine it as from 0 to 100 power, but 100 being 127. A bit confusing, but that's just how the binary works. Okay, so you have the large motor. But doing an if statement like this, well, it's fine for right now. If you do all of your buttons and all of your ports into if statements, it could actually lag out the VEX Cortex because it's not that powerful, and if statements are by far the most computationally intensive task for a computer to do. So instead of doing this, we can just do some simple math. So just copy this, Control C, and then we can delete this part and this part, and we can just do motor. Instead of equals 127, we'll do equals button 5D times 127. So what this does is if the button's pressed down, which equals 1, when it's pressed down, it will multiply by 127 and get you max speed. But if it's not pressed down or 0, it will just return 0 and you won't have any moving motor. This is far better because you're doing everything in one line of code, and it actually handles turning the motor off, because if we go back to our other line of code, how do we know when to turn it off? We'd have to make a whole nother if statement to do that, to say if it equals 0 and then turn it off, which is very counterproductive. So we're going to go back to this. So we can do that, and to make another one, we can just copy this, Control C, Control V, and we'll make this one small motor, and we'll make this one servo. And you want to change the buttons around, otherwise it won't quite work. So we'll use 5U, and we'll use 60. So these are the left and right bumpers on the controller. So, well, this does give you a binary on or off value for each of the motors. A better way to do, for instance, like steering control, you don't want to be either fully on or fully off. You want to have a little bit of analog input, so you can go from 0 to like 10% to 50% to 100%. So to do that, you would want to use the joysticks on the controller. So you want to do motor, say, let's do the large motor, and you want to set that equal to the VEX RT, square brackets, and we'll do CH for channel for the joystick channel, and channel 2 is the up and down channel for the left side, I think. And so you'll just do that, and automatically the max output you can get for the joysticks is 127, so you actually don't need to do anything to this, which is really nice. So you will either get negative to a positive 127, and that's exactly what the motors take in. You can also do this with servos, which is kind of nice. So that's basically it. Keep in mind that this piece will overlap this one, so we'll just take this one out for now so we can test with the joystick. And so now what you want to first do is you're going to compile the program, and it will ask you to save it, and you can just name it test or something. Just click save. So it's going to come up with some errors. Oh, I forgot to add the asterisks when I copied. There we go. So now there's no errors, but you'll probably have a few errors too. You can usually just read what they say down here. So actually, let's back up and look at what those errors said. So basically, it said error expected semicolon. So semicolons, you need that at the end of every command statement. So it found a number instead. It found this number instead of the semicolon. But what it's saying is that it doesn't see why you have just a number there, because you need like an operator to say like add or multiply by this number, because otherwise it's thinking that's the end of the line, and obviously it's not right. And unexpected 127 because it just saw this. So you want to make sure to add in those multiplications, and we will compile that again and see there's no errors. And so after you've successfully compiled, you can just click download to robot once you plug in your VEX Cortex. That's about it for this tutorial. In the next one, we're going to be talking about how to download and plug in and use programs on your VEX Cortex. So I'll see you around.